Good morning, Dr. Pai.
Good morning, sir. And thanks to you for this webinar.
Actually, I should thank you for accepting this. We had a discussion long back that you will be conducting it.
Last time I couldn't come.
We thought that this will be a right time to do this because anyway the lockdown is still going on. We thought that it will be useful for the students and staff.
Exactly. I mean, I want a lot of
and
students
even there are so many people from industry also, they are also interested. We have informed them that this is a session, and I hope some of the industry people will also join to this particular session.
They should.
Yeah,
sir.
they should, because it will be useful for them also. It is not that only academics should know this. Other industry people should also know the technologies, and they should explore how they can implement it in a proper way. And I think you will be the right person to guide them how to do that. We had one session we had last time. I think I informed you also. With C4I4 lab, we had one session on Industry 4.0. It is a Pune-based lab, and they conducted one session.
Yes.
Yeah, and around 40-45 industry people were present that day, along with our academic system. And they disseminated the idea, and then they also have prepared a model so that it can be used for training of people. How it works actually. Some of the technologies put up together, and it is a tabletop model that they showed me in Pune. And they want us to use it in Nasik and train the people. Let us see how it works out in future.
Okay.
Yeah, sir. Sangre sir, chalu karun dyan.
Okay. Good morning to all of you. I am Santosh Sangre, Assistant Professor at Department of Production Engineering. Welcome you all in this webinar on Transforming Towards Industry 4.0 on behalf of KK Institute of Engineering, Education and Research, Nasik. I thank you all the participants for your overwhelming response. I welcome all the dignitaries, session speaker, Wing Commander Dr. Jayesh C S Pai sir, Dr. K N Nandurkar sir, Principal KK Institute of Engineering, Education and Research, Nasik, Dr. P J Pawar sir, Head of the Production Engineering Department. I request Dr. K N Nandurkar sir to inaugurate the function by giving welcome address. Please, sir.
Yeah, thank you. Thank you, Professor Sangre. Once again, I welcome you all the attendees to this particular program. And as you all know, Production Engineering Department is one of the pioneering department of KK Institute. And we are doing a lot of activities for the benefit of staff as well as the industry personnel. And as I was discussing earlier, we had one program with C4I4 lab, and now we are having this another program on Industry 4.0. Our idea is that the students and staff, they should be aware of the future technologies. And I think now we have discussed, and probably Dr. Pai will also be discussing about the first, second, third industrial revolution. And now we are into the fourth industrial revolution. And anyway, there is no scope, as he is rightly saying, that everyone has to understand that, implement that, and then only we can progress in the right direction. So in order to make awareness or create awareness about this among the students and staff, because the students, they will be passing out from the institute and they will join different industries where they will come across these techniques, technologies, and probably they will be involved in implementation of these technologies. So they should be aware of that. And we requested Dr. Pai, because he is an authority in this particular field. He has traveled many places and guided people not only in India but in abroad, and also is associated with very higher institutes like IITs and IIM, where he is guiding the people on this particular technology. So we are really very fortunate to have him with us today. And this session will be very informative. I am very sure about that. I don't have any doubt about that. My only concern is that people who have some questions, they should raise, either they can raise the hand or they can put up in the chat box so that the speaker can answer at the end of this, and we'll try to make it more interactive and try to learn something from him. I think if that is done, that will be the success of this program. So once again, on behalf of Institute, I welcome Dr. Pai as well as all the attendees for this program, and I request Professor Sangre to continue with the proceedings. Thank you.
Thank you, sir. Thank you so much. Today we have very eminent personality for this session, Dr. Jayesh C S Pai sir, Wing Commander. Sir had completed PhD in Intelligent Manufacturing in Industry 4.0 from RWTH, Aachen, Germany. Sir has completed MTech from IIT Mumbai in Material Science, as well as PG in Aerospace Engineering from Air Force Technical College. Speaking about his experience, Sir worked in the Hindustan Computers Limited for 2 years, as well as work in Indian Air Force and MOD for 25 years, as well as Sir has worked in MSME Kolkata as a general manager, also worked with government of Taiwan in Taitra. Sir also have additional experience in plasma spraying from Soldiers, Switzerland, advanced manufacturing technology, Germany. Also, Sir is a lead auditor for ISO implementation. To his credit, Sir have major commendations. Sir have some major commendations as a Chief of Air Staff on 8 October 2006, Best IF Instructor in 1996. Sir is a gold medalist of IIT Bombay. Sir also received Best PhD Thesis Award from RWTH and Max Planck Institutes and many more. I welcome you, sir, and I request you, sir, to guide us to enter in the era of Industry 4.0. Thank you, sir. Welcome. Sir, please start the session.
Yeah, first of all, good morning to all of you. And I really thank Dr. Nandulkar for the webinar. What I'm going to do is, I'm going to keep it very simple so that all of you understand what I'm talking of, a topic which is very relevant and which is going to be the future of all your generation, the young generation which is there, and also a topic which is, a burning issue which is there in all the industries across the world. Now, first of all my presentations are available on SlideShare and LinkedIn. So those of you who want to download it and read it, it's available on both the sites, on SlideShare as well as on LinkedIn, all my presentations. Now, the first point before I start this thing, all of you should understand is across the world, all the manufacturers want to cut down costs. I mean, that's a simple logic. You want to sell more and make more profits. How do we do it? How do we come to that is one burning question. The second point which all of you should understand is there's nothing new in Industry 4.0 or what I'm going to speak of. There's nothing great in the technology development which is taking place. These technologies are already available. If you look at aerospace industries, most of these technologies were available 20, 30 years back. It is now slowly coming into this daily life, the society life. For example, I will talk of digital twins. It was there in the space industry 15 years back. How do you repair a satellite which has already been launched, which is already floating in the space, it is going towards Mars or it is going towards various other planets? How do we repair it? If there is a problem, how do we repair it? So there is a digital twin available on the Earth on which we can replicate the problems or in which we can communicate and sort out the issues. So digital twins was already available in the space industry. It is now coming into your modern day-to-day life and the manufacturing industry now. Similarly, augmented reality, virtual reality, it's coming into classrooms now. Schools are already implementing these technologies. I'll give you one live example of what happened during the Kargil war. When the Kargil war took place, we didn't know where the bombs were. We didn't know where the ammunition was lying. There was panic going on in trying to trace out where all the ammunition are lying. After that war, the armed forces implemented what is known as the ERP systems in the armed forces. But we went a step beyond that. We copied a lot of technologies from abroad and we established an e-maintenance model in which today, for example, if an aircraft is flying in the air, I exactly know which pilot is sitting in there, how much of fuel he is carrying, what armament he is having, what are his problems. In case there is a problem in, say, in a bearing in one of the engines, that will give an indication to the aircraft as well as to the ground-based systems. So by the time the aircraft lands, we know that so-and-so bearing is going to fail. This kind of proactive maintenance or predictive maintenance has been established in the armed forces after the Kargil war. We know real-time information. That's what I'm trying to say. We know real-time information and we can predict things now with the kind of technologies we are implementing. The third thing which all of you should know, I mean, many of you should keep this in mind, why Industry 4.0, what is so great about it? Please remember, Kodak also raised the same thing that nobody is going to change over from paper or the film photography to a digital photography. They didn't change their mindset. Similarly, if you look at Nokia, they didn't change their mindset from a feature phone to a smartphone. Both the companies collapsed. Today we have digital DSLR as well as digital photography. You have smartphones, Apple taking over, Samsung taking over, and you don't listen to Nokia anywhere. Similar is the case with Xerox. They've gone far behind in the kind of photostat machines they were manufacturing earlier. The fourth point which you should keep in mind before we enter this presentation is collaboration. Your principal made a very valid point that collaboration is not only from engineering colleges or science colleges, it is from the industries as well as the government. Now, when I show you the slides, you will understand how collaboration has changed the world. You know, companies used to hide information earlier, but now things have changed. If we don't collaborate, we are not going to go forward in the technological progress which the world is making. That's a very important thing, very important point which all of you should keep in mind. And the fifth and last point which all of you should keep in mind is this technology or Industry 4.0 or the progress which science is making is not limited to engineering field. You can see it everywhere. I'll give you an example of the agriculture industry where we have installed a pilot project. I mean, amazing improvement in the kind of barn management which India has. Okay. So first, let me play a small video for you, which will give you a gist of what I've said so far. Okay, and then we will start the presentation. Just watch this video.
The fourth industrial revolution has begun, and you have the chance to be part of it. This isn't going to be like before. It's not about the steam that powered our factories in the first revolution, or the mass production model that dominated the second, or even the emergence of computer-driven systems from the third revolution that we're living in today. Industry 4.0 is about connectivity. It's an opportunity to radically change the way industry responds to the needs of society. As previous industrial revolutions were led by innovations in manufacturing processes and systems, the advancement of Industry 4.0 will be driven by a smart, interconnected, pervasive environment. The opportunities for disruption are huge, and those left behind will feel it acutely. There is still space for leaders of this new revolution to emerge, but the race has already started. Understanding what current leaders are doing will help you join them. KPMG formally examined what those trailblazers were doing in their factories and their offices, and it revealed some thought-provoking findings. Our research highlighted a number of areas that current Industry 4.0 leaders are focusing on. Leaders are planning ahead with clear strategic vision, driven by performance and tying investment to proven opportunities for growth, progress, and innovation. They are focused on discovering how smart products and processes can be developed. Integration is key. The major players are moving away from isolated silo-driven development with limited scope and value of new projects. Instead, they are moving towards large-scale and proactive integration across their enterprise and among their customers, supply base, and products to ensure they are aware of every possible opportunity Industry 4.0 technology has to offer. And perhaps most importantly, they are not afraid to think big and act bold. This means nurturing innovation, developing disruptive thought processes aimed at devastating the status quo, and looking for opportunity in every element of their value chain, from which products are designed and how they are produced, to who they are sold.
Yeah. Can we start the presentation now?
Sir, yes. Yes, you can start, sir.
Okay, sir. Yes.
Okay. Now, let's first see briefly as to what Industry 4.0 is all about. What I'm going to tell you is actual experience based. This is not from any books or from any article. This is what actually how this entire revolution took place and what is it about. So I'll give you live examples so that all of you understand what it is about. Now, many people call it different names, this Industry 4.0, but the general terminology now is coming down towards intelligent manufacturing. This is something which all of you should keep in mind. In terms of anything which you do with manufacturing or with even scientific research, we are coming down to intelligent planning or intelligent design or intelligent control. This is the first point which you should keep in mind. Also, please remember, don't think that India is far behind. India is quite ahead in Industry 4.0 implementation. If you remember in 2015 in Hanover, our Prime Minister Narendra Modi was invited by German Chancellor to inaugurate the fair. Now, the Hanover Fair is where every year all the industrial manufacturers get together to discuss the Industry 4.0 implementation or the technologies which are now being implemented across the industries. This is Hanover Fair. The second place where these technologies are discussed is the World Economic Forum, which I'll show you separately. We'll play a video on World Economic Forum also. There it is called manufacturing lighthouses. We'll see it separately. So first point, please remember that India also plays a big role in Industry 4.0 implementation. There are many industries across India now which is playing or implementing these technologies quite usefully in various places. Okay. Now, so far, most of the manufacturers were seeing, the world or their factories or their setup in a very chaotic manner. There was no set routine in everybody's planning or budgeting or whatever they're implementing in their factories. What is happening now is the Industry 4.0 is coming down to setting their factory or setting the planning or making sure that everybody thinks in terms of compartments. Well set compartments which when horizontally or vertically integrated, you have a beautiful setup which can talk crisscross with various vendors and also to the customer. The customer also knows what is to be done precisely. This is something which is beautifully coming out with the Industry 4.0. Let me give you an example here, a live example. You know, this I have when I came to your institute a number of times, I have given this example, which I think some of you might not have heard, so I'm repeating it again. 8 years back, Taiwan, which is the most famous place to buy sewing machines, because they are world's leading manufacturer of sewing machines. When they sell a sewing machine, they ask you to install a particular software and switch on the Wi-Fi when you start, stitching on your sewing machine. So if you buy a sewing machine from Taiwan, bring it to your home, you set it up, and when you start stitching something, you have to connect it to the Wi-Fi. Why? Because when you are stitching something, somebody sitting in Taiwan is monitoring you. Not because he wants to see what you're doing, but he's trying to monitor the machine's characteristic. And also what he does is he develops the product based on how people are using the machine. This was 8 years back, and today they are world leaders in redesigning, modifying their products to much better sewing machines. This is something which many small countries have been doing much earlier, but now being integrated into day-to-day life. Okay. What is the main challenge for a manufacturing industry? Which I said in my initial first thing, is the cost pressure. If you look at 1, 2, 3, so the fourth point, everybody wants to buy a cheaper item, but the manufacturer wants to make make more profits. So there is a cost pressure. What do I do? And also the last point, I want to save energy. Energy efficiency is a big issue nowadays. ISO 50000 is a big issue. I want to save resources. How do I do that? This is a major point. So if you look at all over the world, you look at USA, they had the advanced manufacturing policy in 2011. The word Industry 4.0 came from Germany in 2012. Japan had its 4.1J from 2013. Now it has changed to Society 5.0. Korea had the Manufacturing Innovation 3.0, and China had the Made in China 2025. In India, we have Make in India. We don't have any other name for this. It's more of you manufacture in India. Okay. Let's quickly go through the Industrial Revolution. The first revolution, which all of you know, way back in 1712, was the invention of the steam engine. But please remember, anybody asks you what it is all about, it's about using the hand power, mechanical production, using the strength of the man or woman. Then came your electricity, the second industrial revolution. It started somewhere in the 1840s, 1880s, but made famous by Henry Ford in 1920 in the mass production. But it was basically electricity which brought in the second industrial revolution. The third industrial revolution came with the development of computers, but the actual implementation started with the PLCs and embedded systems. So that was somewhere around 1970s, 75. And of course the computers then started coming in, electronics. Now is the age of information age. So like what I told you is, it is not something new. Like US had its advanced manufacturing policy in 2011. We had Internet of Things way back in 2000. GE started it, Cisco had it, a lot of other people did it. In the biotech field, you have cellular transport systems being investigated, nanotechnology injecting medicines inside. And now coming down to autonomous vehicles and virtual reality. Like for example, in Bangalore, a small boy was operated for his heart surgery. They didn't go and operate the boy straight away. What they did was 16 times they did a virtual operation and virtual reality. I think it was a 6-month-old boy. They did the virtual operation first in Narayana Hridaya, and then the 17th time they went for an actual operation. So this is the kind of industrial revolution we are talking about. Okay. And also, all students, please remember, every 1% I am trying to save in implementing these technologies. Each 1% is giving me an enormous advantage in terms of the estimated value would be about, say, if you look at energy efficiency, is about $66 billion over a period of 15 years. I'm talking of, say, one particular sector. So if you calculate various sectors, the savings is enormous. Okay. Now, anything you talk today goes back to China. Many of you may not have known this, but please remember, it is actually China implementing the Beijing Olympics in 2008, which created Industry 4.0, or the need to bring in new technologies into manufacturing industries to cut costs. Okay, because China started investing in infrastructure and manufacturing industry so much during the Beijing Olympics, and there was a big financial crash in 2008. So what happened was, because of the Beijing Olympics in 2008 and because of the financial crash in 2008, all industries got together. Now the word collaboration comes here. What do we do? If we don't get together, one, China is going to overtake us. Number two, the recession is going to hit our industries and we are going to be bankrupt soon. So that's when in Germany, what they did was they got together somewhere in 2006, all these institutes, Fraunhofer, DFKI, Acatec, all these people, and they formed, which was known as the Industry 4.0 document. They said, what we are going to do is, all industries, not only in Germany, across Europe, we're going to collaborate. We are going to use the cyber physical systems to start collaborating. We need to collaborate, one, to get over China, number two, to get over the recession. So if you look at the main people behind this collaboration was Robert Bosch and Henning Kagermann of SAP. So Bosch and the SAP were the main leaders for this, and they became a part of a project from the BMBF, that is Education and Research Ministry in Germany. And the other people involved were from Siemens, Bosch, and of course the Wolfgang industry, Mr. Wolfgang from DFKI, and the Wittgenstein industry. All these people got together, the work groups, and they formulated a document called Industry 4.0. They said, let's start implementing this technological revolution in our industries. Because if you look at this figure, China was galloping ahead at 28.4%, way ahead of all other countries in terms of manufacturing output. India was 3%. This is 2018. Now we are behind. We slipped to, I think, 2.6 now. I don't know 2020 figures, but in the last year's figures we have slipped. So we need to start collaborating, not only the industry as well as academia, if we have to come up to the levels of, say, China manufacturing output. So this team in Germany, as well as people from US and other places, they made 4 design principles. Now listen to this very carefully. Anybody from any industry or any college or anyone has to understand these 4 principles before we go ahead for implementing Industry 4.0. First is information transparency. This is the main design principle which is a big failure in India. I have to give information in a very transparent way if I want to succeed in implementing Industry 4.0. There is no other way. I can't hide information. That means the top management cannot hide information, and also the bottom level workers cannot hide information. If I want to succeed in implementing Industry 4.0, the worker has to be transparent, the top management has to be transparent. Now, this in India is a very, very difficult proposal. But across the world, if you see in other places, it is being done. In India, yes, we have started. A lot of places, Tata has already become a manufacturing lighthouse in Kalinganagar, the Tata Steel plant. So, any industry wants to step forward in implementing Industry 4.0, number one, please remember, you have to be transparent, right from top to the bottom. You cannot say, I will hide my financial data from others so that they don't know what is happening in my finance department. No, you cannot hide information. Similarly, in colleges, departments can't hide information from others. We need to be transparent. So this is the first thing which you have to understand. The second thing which you have to understand in Industry 4.0 is decentralized decisions. When I get data from my sensors, when I get data from various places, when I'm doing data analytics, my decisions become decentralized. It is not that one single central place start taking the decisions. So some of the cyber physical systems like robots can make decisions on their own, and they can perform their task as autonomous. So many PSUs find it very difficult to accept this. I as general manager will take a decision. No, in Industry 4.0, it has to be decentralized. You cannot become a central power. So this is the second point which all of you should understand. The third point, which is can be easily applicable, is that all these cyber physical systems actually physically support humans by conducting a range of tasks. Now, the difficult point in this is, if I bring in a robot in my company, or I install an AI in a bot in my system where it can talk to a customer, some jobs are cut. Yes, a few jobs will be lost. But there are other areas where jobs will come in. So this we need to keep in understanding. I'll show you how the other jobs come in. And the fourth point, which all of you should understand, is the interoperability, or some people call it Internet of Things, is that you can start communicating man to machine or man to man or machine to machine. There are a lot of communication which is going to take place, and this is a must. We need to, when I'm talking of collaboration, I need to talk, I need to discuss, I need to make sure that machines talk to machines, machines talk to man, man talks to machine. I mean, this is something which we have to. So these four design principles are paramount in Industry 4.0. If we don't have this understood, then you cannot go forward with Industry 4.0, especially transparent information. I hope all of you have understood this. Okay, now another point which all of you should understand is, this is actually, I'm jumping the slides, but I want you to keep this in mind when I'm talking later on, is that today when I'm talking of say a sensor, I'm talking of precision. I want to get some fault detection from that sensor. When I'm talking of, say, a controller, I'm talking of condition-based monitoring. When I'm talking of a network system, I'm talking of lean management or lean operations. how to reduce waste. This is what I'm talking of in today's factory. But in Industry 4.0, I want a worry-free productivity. So I am talking of manufacturing anytime, anywhere. Now this is a a thing which all of you should understand. If I produce a Volkswagen car in Germany and I bring it to India, I should be able to manufacture its part in India where I want with a 3D printer or a CNC machine. Manufacturing anytime, anywhere is what Industry 4.0 is all about. That means I require systems which are self-aware, self-predict, self-compare, self-configure. Make it very simple. If I want a particular part, say one of my aircraft parts has gone wrong, do I wait for the part to come from Russia, or do I wait for the part to be manufactured and then it is sent from Russia? If I have the drawing, can I manufacture it here in India, right at the place where I want it? That is what Industry 4.0 is all about. Okay. I told you a lot of people call a lot of names. So the French people call it the Liaison the future, that is factory of the future. Some of the US people call it SMLC, the smart manufacturing. In Korea, I told you it's manufacturing innovation 3.0. The Chinese call it made in China 2025. The Taiwan people call it productivity 4.0. Now, why I want you to know productivity 4.0 is this point. That is, in Taiwan, in Japan, in many other countries, they don't have labor. A lot of people are getting old and the youngsters are reducing. What to do? When I am having less number of people, how do I improve my productivity? So do I bring in more robots, or do I bring in more automation and change my productivity or increase my productivity? This is something which these countries are researching. In India, we don't have a problem. We have labor. We have plenty of labor. But the thing is, we should adapt these technologies because it is helping in increasing the efficiency as well as increasing the productivity. If you look at the productivity increase in Taiwan over the last 4 years, it's an amazing 34% increase in productivity. Amazing. I mean, if you look across any industry in Taiwan, it's about 34% increase in productivity. This is a World Economic Forum statistic. It is not my statistic. Okay. Also, please remember, when I'm talking of Industry 4.0, people have already started going ahead. Industry 4.0, they say, is the information society. Let us go one step ahead. That is Society 5.0. So Japan, for example, has already started implementing what is known as the super smart society. That is an imagination society. If a customer imagines a particular product, he should be able to get it. Or if a customer imagines a particular kind of health service he wants, he should be able to get it. So they have already started going towards implementing what is known as an imagination society. Okay. So I briefly skip this. This is what is about Society 4.0. Basically, what we are trying to look for is a better human life. That means, like what I told you right in the beginning, this is not limited to engineering field. It is going to go into science, health, whatever industry you want to think of, banking, finance, everywhere. All these technologies, Industry 4.0 technologies, is going to lead to a better human life. And that is why implementing Industry 4.0 is key to now progress in our country or anywhere in the society. This is proved that we need to accept this. We can't stay backwards. Otherwise, the train is going to leave and we'll be left on the platform. And that is why in particular, and many other people, we are keeping on talking of this implementing Industry 4.0 across India, across engineering colleges, across industries. For God's sake, please accept it. We need to implement this if we need to progress. Okay. One thing which I would very emphatically is the old traditional factory which had higher production costs now lead to lower production costs in the new smart manufacturing plant. This is proved in all manufacturing lighthouses, some of which we'll see. This is what manufacturing companies wanted. They wanted lower production costs. It is being done. Number two, today, if I buy a mobile today, in 6 months that mobile model is changed. There's a different mobile model which is coming. So it's a faster time to the market. This is established. Number three, if you look at from the worker side, I get higher pay. Earlier it was lower paying unskilled jobs. Now I'm getting higher pay. So that's why if you look at Europe, US, the pay is much, much higher than what we are seeing in countries like India or in China. But the most important point which all, I don't know whether industrial people are there in this presentation, is we are looking at higher output as well as higher productivity in a smart manufacturing plant. This is something which has been, again proven in World Economic Forum statistics. Okay. Now, the most important point, do I lose jobs? Am I going to lose jobs if I bring in Industry 4.0? If I bring in robots, will I lose jobs? If I bring in bots, will I lose jobs? No. Yes, some amount of low-paying skilled jobs, unskilled jobs, you will lose. Lower-level workers, there will be a loss. Yes, but if you look at that is why the Government of India has brought in a skill development ministry, and this is something which I've been talking to many people across Nasik. You need to bring in skill development even for the engineers, because Industry 4.0 will require higher skill development or higher skills. How do we get it? We need to. This is where your colleges and industry need to sit down and discuss. Okay. Which I keep talking of. I'm taking some time in telling you all this because please, for God's sake, please keep these points in in your mind. Is Industry 4.0 requires collaboration across horizontally as well as vertically. So in these disruptive days, collaboration is very key. We cannot progress without collaboration. Look at Germany. Today, BMW, Audi, Skoda, everybody, I mean, whichever car industry you see in Germany has joined their hands and they are now collaborating. All vendors have now joined hands with all industries so that the supply chain is made regular. That means the vendor doesn't hide information now from industries. Earlier it was, if I require a part, I ring up the vendor and say, hey, where is my part? The vendor says, it's coming on the way. Gaadi nikal chuki hai. But practically speaking, the vendor may not have dispatched the part. This happens in many places. It's like that you call for a taxi and you keep waiting. The taxi wala says, I'm coming, I'm on the way, just 5 minutes. And then he reaches you after half an hour. In Industry 4.0, you can't hide this information. The manufacturer, the vendor, the supplier, the customer, everybody is connected. So what happens in the vendors industry is known to the manufacturer also. The customer knows precisely what has happened to his ordered item, real-time information. This collaboration everywhere, in design, in production, as well as in supply, everywhere this collaboration is very important. Okay? So knowledge intensive, high skill talents, all of you will understand this. And I've already given you an example of that location is less significant. Today, I'm not bothered about where I'm supplying the item because I know that I can manufacture that part at that particular location itself. Okay, we have already looked at the origin of Industry 4.0, so we will not go into much of this thing, but I repeat, the first industrial revolution is the labor, the second electricity plus labor, the third is of course your electronic systems, and now I'm looking at mass production, mass customization, local production, but basically cutting down costs. I want to connect with the physical world with the virtual world. That is key to my production because I require a digital twin to understand what will be my item which I produce. I'm not going to make a prototype in today's world. I will not design an item, make a prototype and then market it. No. What I'm going to do is I'm going to make a digital twin first. It's all there in my simulation model on the computers. I digitally simulate it. I see what the product is. I test it on the simulation and see how it fares. And then I actually go for producing the product. I can also keep a track of how the product performs with RFID, stickers and all those things. I can monitor it lifetime. So this is the kind of revolution which is taking place by integrating Internet of Things with the manufacturing process. Now, one thing in this we need to understand, and which is already taking place in many colleges across the world. Today, your department, the silos which are there is going to collapse. You can't have a mechanical engineering department, a production engineering department, or a computer science department, because in the future all these are going to be networked, interlinked. A mechanical engineer has to understand what it means, what data analytics means, or what big data means, or how the sensors are going to give him data, or how he's going to analyze that data. Similarly, the production engineer has to understand what you mean by how I can increase the productivity by using this data. So all these digital enabling technologies has to be understood by each engineer. A computer science engineer has to understand how a CNC machine works. Otherwise, he will not know where to fit a sensor and how to get the data. So these silos are going to collapse in the near future. We're going to have people, maybe you're going to have something like the MBBS, in general, a doctor. So you'll have an engineer with a general degree, and then maybe he specializes in computer science or in material science or in some other thing in his master's. So your graduation is going to become a general engineer field where you're going to learn everything across the board. This is what the fourth industrial revolution is bringing about. It's there already being seen in the developed countries. Okay. Now, what is Industry 4.0? I already told you that there are many technologies which is already existing earlier. Okay. So there were 9 key technologies which were prevalent in many other places, maybe in the aerospace industry, maybe in the space industry, maybe in the education field. These 9 technologies became what were known as the pillars for starting the Industry 4.0 and integrating them. That is, horizontally and vertically integrating these technologies. So key to that was the big data and the analytics. Starting from this, then the usage of robots, documented reality, the 3D printing, additive manufacturing, the cloud, which is now becoming very, very key in implementing Industry 4.0. Some of you may have known of edge computing, then of course IoT and simulation. When I talk of simulation, many of you are going to work in this field. This is where a lot of Indians are doing good work in Industry 4.0. Amazing amount of work is being done in this field, as in the last pillar, which is cyber security. How do I secure my plant against hacks? Now let me give you an example here. One of the German foundries, high-tech German foundries, he was manufacturing for almost all automotive industries, got hacked by the North Koreans, and what they did, they melted his blast furnace, his furnaces. They hacked into the system and they melted the furnaces because of a loophole in the software. This was about 4 years back. Since then, cybersecurity has become a key area in which a lot of people are working. Okay, today these technological pillars have slightly changed, or I would say slightly progressed into these. Now I'll take 1 minute on this slide, please understand. Today cloud computing has become the key area. If I don't have the information on cloud or on edge, I cannot implement Industry 4.0. I can get a huge amount of data analytics from all my sensors. Okay, here one thing please understand, I don't have to change my industry completely, in the sense I don't have to buy new machines to get data and analytics. No, I can use my old machines with a few little bit of modifications. Maybe about 20 to 30% of technology or new machines may have to come in, but 70 to 80% of my old machines are going to remain. When I'm talking of new machines, it is going to be only robotics or 3D printing. Nothing else is going to change. How will the machine talk to my cloud is something which a lot of people are working on wireless protocols, but I would suggest all of you forget these old technologies, look at 5G, because 5G is changing the world, the manufacturing world tremendously. Look at the Nokia factory in Finland, as well as the South Korean factories. 5G has completely demolished all these wireless protocols and everything. Today, a machine can talk to anything via 5G in the fastest possible way, and I can analyze data much better. So look at 5G. I mean, don't look at the other technologies at all. So cloud computing and big data. Robotics and 3D printing, we have already seen. 3D printing or additive manufacturing, which you can think of. Mobile technologies, it was not there 2 years back, but today your smartwatches, mobiles, tabs, everything is now ruling the industrial world. We cannot say ki I will wait for maybe 2 years later I'll implement this. No, this is something which is taken by a storm. A new thing for some of you, but some of you may have seen in your Amazon packages which you get at home. You must be seeing these RFID stickers on that. Now, RFID has had changed the automotive industry 20 years back. Today, it is transforming every other industry which you can think of. I'll give you a small example. If I have an RFID sticker, say on a small part inside, say, your bike. Okay, now that particular product has become non-functional. It is not working. So when I take it to the service center, what he does is he scans the RFID. It will precisely tell him what is that product, what is the product's name, who had manufactured it, when it was manufactured. It will also tell him the current availability of this product, where this product is available. In case it is not available in his shop, in a service center, it will also tell him where it is available, in which particular city, or from where he can order it. Or if he has a 3D printer there, the RFID sticker will give him the drawings, the images, the powders required for 3D printing, and he can manufacture the product then and there, right there in that particular place. IoT is something which all of you must have heard, and all of you must have learned. So I'm not going to expand on that, but go a step forward. What GE is doing, that is General Electric, industrial Internet of Things, IoT. That is something quite interesting, which may dominate the field in the next 1 or 2 years. Cybersecurity is already, which I have already told you, and machine to machine. There's one more field which is interestingly coming into Industry 4.0 is the drones. I'll show you a drone which is transformed 2 of the manufacturing lighthouses. Drones are being used now extensively across many industries. One good example is the petroleum industry, where drones are being used to check the pipelines for any leakages. Drones are being used to check the pipelines for proper flow. Drones are being used to map. Drones are being used in mining industries to see how things are working out. I mean, an amazing amount of usage of drones. So the pillars are keeping on changing. From 9 pillars, today we have come to 10. We may go on to 12 by next year. Drones is definitely going to be added to this. Okay, somebody asked me this, where is India working currently? I know in which fields can we work on. So right now, for example, the maximum number of projects which I am seeing is in digital twins and simulation, in computer-aided manufacturing and 3D printing, in augmented reality, virtual reality, amazing number of projects which we are seeing. In the robotics field, a lot of work is taking place, especially from, of course, with IITs. Big data, massive amount of work is going on now in India. Artificial intelligence, you must have seen a lot of colleges in bringing in this. And of course, the sensing, the sensors. But please remember, the hardware, most of them, 99% comes from Taiwan. It's only how we connect it to the machines and collect the data is currently being worked on. A new field which is taken over in India is the 5G. Wherever people have implemented this, a lot of work is going on in connecting the machines to all this and then collecting the data. Okay. Another question which everybody asks me is Industry 4.0 limited to only big companies? Is it only limited to Bosch? Is it only limited to Siemens or Schneider who are successful? No. It is much more successful in smaller companies. And the amount of manufacturing lighthouses which have come out in the World Economic Forum, this thing, amazing. I mean, the kind of small companies dominating now the Industry 4.0 field is growing much more than the bigger companies. Okay. Okay. Now, I'm very proud of this. So I'm going to talk to you about this for maybe a minute. Very recently, we had done a pilot project for the Government of India that was on the barn management. In one of the barns in Punjab, where you store grains, we implemented a pilot project in that just to show how even the agriculture field you can implement Industry 4.0. Now this particular barn, for example, did not have any temperature monitoring systems or storage management systems. It was dominated by the people working there, and nobody had any idea of how many bags of grain are being stored, whether there are rats entering the barns, whether there was no monitoring at all. It was basically a manual. The minimum IT thing which you could have seen is a computer being maintained there, which had said, "Ki so and so had brought in so many bags, so and so had brought in so many bags." That was all you could see in the computer there. So what we did was a complete sensor-based monitoring system where you can check the humidity, you can check how many grains are there, how many bags of grains are there, what is the temperature inside the barn, and the most important thing, how many rats are there inside the barn. So we had pressure sensors installed in various places which can pick up even a small rat crawling on the floor. And we showed that there was, I think, in the month of January we did this. By about March, we had about 2 to 4% saving in terms of the grain loss. And the most important thing was, the statistic is not fully clear on this, but I'm just this is a guesswork. There's going to be near about 30% saving in terms of grains due to loss, either due to the rats or due to the the humidity. Because a lot of bags were being thrown out because of the bags being soaked with due to humidity and maybe due to the rain. This efficiency has definitely been increased. We have now gone towards implementing this on the farmhouses also. So the quality of the crop can also be improved. Step forward, the farmer sitting in his house now can monitor on his tab what exactly is the condition of his crops in the field, as well as what is the condition of his grain inside the barn. Sitting in his house, he can monitor in his tab. Each one has been given a tab where he can monitor this. So this is the level where in the agriculture field we have implemented this. This is the pilot phase. If required, we can go to a much bigger phase. Okay, there are some terminologies which some of you should understand before I show you the manufacturing lighthouses. One is the cyber physical systems. Don't think that it's something complex or a digital twin. When I'm talking of digital twin, nothing great. A cyber physical systems is nothing but when I'm combining all these, my machines, my man, my supply chain, my security worker on the gate, everybody, I'm combining that into one single entity. That means I'm talking to everybody now. So my vendor also knows what I'm doing. I know what the vendor is doing. This is cyber physical systems. I can communicate with everybody. Communication is very crucial. Collaboration is very crucial. So I can have sensors, I can have chips, I can have embedded systems all doing these jobs. But one step forward in this, in cyber physical systems, is digitization or digitalization. So that's why I said the field between mechanical engineering, production engineering, computer science, electronics is all collapsing. Digitalization is something which all of you should understand, which all of you should learn. Data becomes more and more important. Data analytics becomes more and more important. If I have to understand cyber physical systems, CPS, then I need to understand data. I need to understand data analytics. So all of you, for God's sake, please do some data analytics courses to understand what is digitization or digitalization. Okay. So big data analytics is something which all of you should learn. Don't think that I will not be a part of this. Your generation, you're going to see massive amounts of data being gathered, and all of you are going to work in this field wherever you are. I have already explained to you, whether you are in agriculture, whether you are in banking, whether you are in manufacturing, you're going to work in this 100%. So you need to understand what is big data analytics. You need to understand artificial intelligence. You cannot now say that artificial intelligence is for the computer science guys or for the electronics guys. No. We need to understand what is artificial intelligence. We need to understand machine learning algorithms, at least the basics. We need to learn how I can use artificial intelligence. Colleges have to understand that AI is something which is not only the future, it is going to transform everything across the board. Okay. Sensor systems, all of you need to go deep into this. Open your electronics books, open your computer science books, go into wireless communication technologies, look at the temperature sensors, the pressure sensors, the humidity sensors, the weight sensors, the vibration sensors, go into all this, learn them. You need to understand how they work, how they will give you data, and how you can use this data. You need to understand this. All of you should learn sensor systems. Okay, now before I go into manufacturing lighthouses, you need to understand one most important aspect of Industry 4.0 is that it is predictive. Like what I told you, I know when that aircraft is going to fail because the bearing has already told me, okay, I am going to fail, I'm going to land now, so please change me. The bearing has already given the indication. Predictive failure. I know when the robot is going to fail, so I go and repair the robot before it fails. I know when the system is going to fail, so I repair the system before it fails. Real-time defect control. I know what error is taking in my production, so I repair that error before it goes into the product. So my quality increases. That is the level we are coming into in production. Okay. Okay. Now, many mechanical engineers, production engineers, even others engineering fields, we forget to learn cloud computing. I'll go a step further, go to edge computing. Cloud computing, fog computing, edge computing, please learn all this. It's easy to learn cloud computing, but at least learn what is edge computing. I'm not going to go deep into this subject. It's highly mathematical, but very interesting. At least learn the basics of this. How we can collect information from the edge nodes. Okay. Connectivity, I've already told you, forget about wireless and all these things, go straight to 5G networks because this is the future. Learn 5G networks, devote a lot of time on this. This is how you're going to already be in the train which is fast forwarding to future. Now, those of you who are learning computer aided manufacturing, all these softwares, there are many softwares available. I'm not going to recommend any particular one. The French one, the data system, that is quite good, but it's a bit tough to learn. But for 3D printing and for CNC machining, you need to learn any amount of these courses. Additive manufacturing, you need to learn some of these courses, design courses. So please do learn some of these things. And last, before we go into manufacturing lighthouses, is of course this simulation, digital twins. I have already given you the example of the satellite. How do I repair the satellite when I launch? After I have launched, how do I repair it? It's already in space. I cannot go to space and repair it. So I need to test my repair on ground on a digital twin and then send my signal to the actual satellite or whatever international space station. I'll go one step forward in this. Some of you are interested in simulation, go to product digital twins. You're going to learn product design, do product digital twins. This is a field, exciting field, which is now in India, a lot of students are working on. Okay, how to design a product in a digital twin fashion and then do the complete thing. For example, testing it, seeing how a customer will use it till it breaks down, how it can be repaired, how the customer can be satisfied, can be virtually simulated. So product digital twin is an exciting field. Production digital twins, those of you who are interested in working in factories, I've already talked about predictive maintenance. You can work on production digital twins, analyzing data which can come from the production data. This is a field when not many are working now, but I am going to see a lot of students coming into the production digital twins. The last field where in India I'm not seeing much of activity except in IIT Bombay is the performance digital twins. How does the product perform? Now for this, a huge amount of data has to be captured and then analyzed. Big data in a much bigger way. Performance digital twin. Only 2 or 3 industries in India presently working on this, but that is because not many universities are taking up this. They think it's complex. It is not complex. It is easy. So some of you want to learn this, you can definitely learn performance digital twins. 3D printers I've already spoken of, but many industries still think this is not required for them. They need to look at what is happening in Europe. The best example is look at what is happening in Vietnam. Even a small scale manufacturer has a 3D printer installed in his place. He doesn't go and buy a spare part from the, say from Europe or from Taiwan. He manufactures it in Vietnam. So we need to, and in this, a lot of you should look at metallurgy, material science. Why I should learn metallurgy? This is the reason. You need to learn the powder terminologies and of course the powder, how to use the powder to manufacture the printed parts. Okay. I'm not going to go deep into the robots because that's a separate lecture itself. And also on augmented reality, virtual reality, not much of, I would say, work from your kind of colleges because this requires a little bit of, kind of PhD level work on this. But yes, colleges in India are working. Some of you who at your graduation level, if you are interested in the health field, how to help the doctors and how to help the pharmaceutical manufacturers, you can definitely come into this field. You can certainly work on augmented reality and virtual reality. Okay. Now, since we're going to run out of time, let me straight away go into manufacturing lighthouses. Now, Professor Sangle, was the video clear the last time I played it?
Yes, sir. Yes.
Hello?
Yes, sir.
Okay.
Video is clear.
Clear video now. Okay, let's watch the video and then we'll come back to manufacturing light houses.
It's really changing the game. There will be a fundamental shift in what consumers want and need. They want it faster, they want it customized, they want it personalized. So all of your value chain has to be designed around it.
Almost all companies are doing something around digital and analytics, but many of them have not really found a way to scale.
Companies are stuck in what we defined as the pilot purgatory. They are trying thousand flower blooms approaches and are not very focused on how they are really creating early business impact for the very first time. Advanced manufacturing technologies are helping companies transform the value chains end to end and develop new business models. Lighthouses are the most advanced factories in the world, so are points of light for the broader community of manufacturers. We defined by 3W. One is a work reduction, how to be leaner, and one is a waste reduction, how to be greener, and worry reduction, how to become worry-free. We have changed almost all of our product definition, configuration management, ERP system to be faster. That's the thing. They are hyper-connected, which allows them to have all the devices synchronized and be able to make the most out of the data.
We decided early stage to focus on robotics, on sensorics, on analytics, and on visualization, all that embedded in an end-to-end connectivity environment.
We have more efficient in terms of maintenance, in terms of deliverable, in terms of reliability.
We've seen benefits in terms of cost savings. We have seen opportunities to accelerate product introductions. We have seen the capability to actually upskill our people.
Every year we train our workers on data sharing, information, performance improvement in production. And then we train them on the usage of the technical tools, the digital tools.
We want to leverage digital to augment their capabilities, eliminating the unsafe, the repetitive, and non-value added tasks of the supply chain.
There's huge benefits on a sustainability standpoint for being a lighthouse. We're able to very accurately understand what our waste is. And that's not just material waste, but also energy waste.
There's a nimbleness and there's an efficiency that comes with applying these principles that today make business sense. They will soon be required in an economy, in an environment, in a world that is cycling much faster than it is today. There is room for companies to be working together, learning from each other, and establishing new partnerships.
Hello, Pai sir. You are not audible. Hello. Hello. Hello.
हे होत नाही का पुढे ऐकून गावात
Hello. 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 Pai sir, you are not audible. Kindly change the setting. Hello, Pai sir. Hello. Hello. You are not audible, sir. Hello.
Is it coming now? Is it coming now? Okay. Okay, sorry for the interruption. Let's come back to manufacturing lighthouses. There are two things which you need to understand from that video. One is end to end. See, what the World Economic Forum has done, the previous slide. What they have done is they have identified 44 factories around the world and made them manufacturing lighthouses from whom you can learn and copy how to implement Industry 4.0. Okay. So there are 44 factories which have been recognized in the past 2 years across the world from whom you can learn. Now, important thing is collaboration. I need to collaborate. Is left behind Tata Steel. One plant in India, Tata Steel Kalinganagar, is a manufacturing lighthouse. Manufacturing lighthouse means they are end-to-end Industry 4.0 compliant. Anything inside the factory, even the security chap on the gate, is linked to the the company ERP system or manufacturing execution system. The boss sitting anywhere, wherever he is in the world, exactly knows what is happening inside the factory. The information is transparent. Nothing can be hid. The worker cannot hide, the boss cannot hide information. And all their machines, all their products are talking to each other. So remember those 4 design principles which we discussed in the beginning. So all these 44 factories around the world have been recognized as manufacturing lighthouses. Lighthouses means the ones who, exactly like the lighthouse, they give powerful light from which you can know what is going on. So it was key to maritime navigation. Now it is key to the manufacturing industries. Now this is a huge presentation, so I'm not going to go through the entire presentation. You can download it from net and see it, but in particular I'll show you 4 slides, 4 or 5 slides which will explain what I'm talking about. Now first is this. is the fast radius UPS company. A question often asked by many Indian manufacturers, by many Indian companies is, I am a small company, I am a medium company, why should I implement Industry 4.0? Look at this company. All he does is 3D printing in Chicago, US. But he has implemented Industry 4.0 across his small factory. And what is the saving? 50% in terms of powder, or in terms of manufacturing cost, or in terms of customer satisfaction, in rejection, whatever you can think of, it's around 40 to 50% savings. And the best thing is, he works 24 hours now. His turnaround time is, I think, almost reduced by half. And they are now gone into setting up fast radius factories in many places in Europe. Now they are slowly coming into sectors in Asia also. Not in India so far, but they are thinking of doing that. So this is a prime example of how a small company can succeed. Okay. I talked to you about drones, so I need to show you the drones. Just give me 1 minute. We come back to the lights off factory in the next slide. Yeah. Now, the Saudi, the biggest gas plant which you can see on earth is the Uthmaniyah plant in Saudi, owned by Saudi Aramco. Now, they started, it's also an end-to-end Industry 4.0 compliant factory, where you have digital helmets worn by workers, which have got cameras in them, which can give data to the, there is a centralized system which I'll show you. And the biggest thing which they saw using drones as well as by these helmets is that inspection times are cut by almost 90%. That's a saving which is unimaginable. Now, those are the kind of drones which is used by the Saudi Aramco plant. And you see, if you go to the plant, you'll see about 10 or 15 of them continuously hovering in various places. And I believe one of them has even got face recognition technology from the Chinese guys. Because if you walk into the plant, it can recognize you. So it can track workers walking around the plant using face recognition technology. Now, these Saudi Aramco chaps have even, built a fourth industrial revolution center inside their plant. So they have, if you go to that place, you'll think you have entered Jurassic Park. You see those kind of pods there where you can sit and watch the entire plant. You see the drone hovering around their plant there. But this is what is amazing in that plant. It's exactly like what you see in an ops room in the armed forces. If you go to an ops room or a war room in Delhi or in, wherever the commands are located, if you go to an ops room, this is what you will see. You will see hundreds of screens, but now Saudi, and of course even in Taiwan they have this. They have one centralized LED screen which is monitoring the entire plant. And these are touch screens. So I can even send command signals from these touch screens here. I can monitor the entire plant sitting in one place. And that's why I said information has to be transparent. It has to be collaborative. I can even monitor what is my supply outside. When I'm supplying it outside from Saudi Aramco, I can even monitor it from here. That is the level they have gone into. Okay. Okay. Now, I'll come back to another slide called the lights off factory. Many of you might have heard about this, but I want to show you this. Many of you purchase mobiles, Oppo and Apple, and I think what is it, OnePlus and all those things. All these come from a factory of Foxconn. Now, if you go to the Foxconn factory, this is of course in China what I'm showing you, but Foxconn Taiwan is also the same kind of system. You will not find a single light inside the factory. There is no worker inside the factory. The entire factory is workerless, its lights off. It's amazing. I mean, it's something which is difficult to believe. After what I'm showing you is the electrical factory which they have in Shenzhen, where they manufacture electrical machines, because they didn't allow us to enter the mobile factory. But this, if you see, there was an efficiency gain of 30% and stock cycle by 15% by working workerless and manufacturing in the dark. And you can imagine the energy efficiency they had. I mean, it's rumored to be around 70 to 75%. They have saved energy. And of course, they use solar energy mostly. So I'm sure they may not be paying any electricity bill at all. Now, those of you who are interested in cloud computing and edge computing and fog computing, they have an interesting AI artificial intelligence system known as Fog AI, which works on mobiles. And this is, from Foxconn to their vendors to their retailers. Suppose there is a retailer in India who is selling Foxconn mobiles. The entire information is linked through this mobile app to the Foxconn system. So I can, if I'm a Foxconn employee, I can track what the retailer is selling, which mobile he has sold, what is the number of that mobile, everything can be tracked. And now they have got a step forward, like what Apple has done. They can even track your stolen mobiles down to, even if the SIM card is changed, I can track the stolen mobile to where the exact location, the GPS coordinates can be found out. That is the level which they have gone into. Okay. Another thing which I need to show to you is I'm talking of robots or cobots inside the factory. I am now looking at helping the worker to work inside the factory. Now this is a Germany plant, ACCO, who manufactures tractors, something like Mahindra and Mahindra, okay? Now this is a Ford exoskeleton which is used by the worker. This exoskeleton is fitted onto the body, and the worker can utilize it inside the plant. It reduces his, fatigue, because it is helping to increase his muscle power. So if he has to lift a heavy product, this exoskeleton will help him in reducing the weight which he is lifting. And also it helps in reducing his, because most of these factories, unlike in India, most of these European factories or in Chinese factories, you don't see chairs. They can't sit down. Once he starts working, he is working. So these exoskeletons actually help in reducing fatigue level in a huge way. And I'll show you one more exoskeleton. This was seen in the Brazilian plant of Renault. This is a Renault exoskeleton. So this is how the workers are working. Okay, now this is quite a heavy duty engine in which they are working. And only you'll find two workers in the entire section. Using these exoskeletons, both of them will be working. A beautiful example, and this is now a fully Industry 4.0 compliant factory. This is in Brazil, Renault plant. So those of you who are interested in seeing manufacturing lighthouses, where they are and what technologies they have used, I have, this presentation is available. So the key technology used by that factory, I have shown a photograph of that. I think one more, yeah, this is an outstanding example of an Industry 4.0. This is a drilling plant on the sea in Brazil, in Rio de Janeiro, Monac plant. It's there on the sea, it's used for drilling, but this complete drilling platform is Industry 4.0 compliant. They use drones, they use every technology which you can dream of, including simulation, to keep a track of what they are drilling, how they are drilling, increasing the efficiency, which worker is working where. Everything is being tracked real time and being monitored real time. I mean, can you imagine a ship, in the Pacific Ocean, in the Atlantic Ocean, sailing in the Atlantic Ocean, having Industry 4.0 compliant and being used for drilling? It's unbelievable, but they have done it. So that's why I said that these technologies are coming into every field which you can think of. Health, I've already given you an example. Agriculture, now this is another example. So you can go through this presentation and you can see that there are 44 lighthouses which are now being declared by the World Economic Forum. Okay, now before we end our presentation, I will briefly come to the main topic which we were discussing. See, this presentation is actually a little bit high level. I can give it only if people really understand what is Industry 4.0 and how it is being used. So I didn't go straight away into that because unless we learn what Industry 4.0 is, it is very difficult to understand what we are talking about. Now, there are 3 slides in this presentation which all of you should understand. If I want to move forward, if I want to go forward in transforming towards Industry 4.0, the way forward, now it is being recognized, or every industry is accepting that there are 4 things which we have to implement. One is the smart solutions. The second is the smart innovation. The third is the smart supply chains, and the fourth is smart factory. Briefly, I'll tell you what are these things. When I'm talking of smart solutions, I'm talking of both the smart products as well as smart services. So every product of mine has to be smart. So when I told you about the sewing machine, please remember, the sewing machine is a smart product. It is monitoring how I use that machine. So if a particular part in that machine breaks, for example, the bobbin case breaks, through the Wi-Fi, the Taiwan dealer gets a, this thing that so-and-so bobbin case is broken. He sends you the part immediately. Or if he is not able to send you the part, he will immediately tell you through an email that where that part is available. Nearest location where that part is available. Smart product. This is important. So which smart product? Smart services is very important. So that's smart solutions. When I'm talking about smart innovation, unfortunately, this is something which we seriously lack in India. I'm talking of extended innovation and connected life cycle innovation. And I'll not go into the depth in this because we have to traverse a huge distance in this. When I'm talking of smart supply chains, the third one is, please remember, those of you who are interested in agile, studying agile model, this is the future. So agile collaboration networks is something which you can learn. And of course, I've already explained to you. That means the vendor has to be connected to the manufacturer. Smart factory. Smart factory is nothing but the first part which I told you in the beginning, that is decentralized production control. There is no single boss. There is a decentralized data-driven decisions which are being taken. And the second is, of course, the data-driven operational excellence. I need to collect data and analyze it and use it for excelling my or increasing my quality. And to help this is all these pillars which we have already discussed. Okay? The 9 pillars or 10 pillars or the 12 pillars which we are going to see in the near future. Now, if I have to implement the smart services, smart supply chain, smart factory and all this, what as an industry, if I'm an industry owner or if I'm going to start an industry, what should I do? Okay, 4.0. Now let me give you an example on this. This is in Hsinchu city in Taiwan. The entire city, the lighting solutions are linked, connected to a centralized data monitoring cell. Why? And it's all one single manufacturer. Okay, he's a large manufacturer in Taiwan. One, he has increased the sales by installing so many lampposts and light bulbs. One. Number two, these entire lamppost light bulbs are connected to a cloud server where the sensors are measuring the data. So the light is being controlled whether it is required or not. For example, in a particular place where there's not much of movement, the light is dim to a certain extent. If a particular place has much more people and much more activity, the light level is increased. So energy consumption is, of course, you can yourself guess, it has been drastically reduced by about 40 to 42%. There is more road safety to the extent that even if a single woman is walking on the road, automatically the level goes up. That is the kind of level of monitoring they do. And look at the manufacturer. He has recognized this value of this data and he has now transformed his business model from a product-based one to smart services. That is a smart product and a smart service. So he is a huge manufacturer in Taiwan. But from 50% say profit earlier, suppose he was making $50 million earlier, today he is making $300 million. The 6 times increase is what is happening because of coming into this kind of smart services. This is practically happening. If you look at the manufacturing lighthouses and all those connected industries, when I mean connected industries, the vendors, the profit is increasing, the productivity is increasing, the quality is increasing. What should I do? A future business model. Like what I told you, we need to have an innovation-driven one. We need to innovate. And this is something which the US guys are doing tremendously. So any college in the US you go, we need, from our colleges, we need a lot of innovation to come. We need, the second point, to look at extremely agile production. We need to look at customized products. What the customer wants, what kind of car he wants, the customized car I want. I don't want to sell a standard car. I need to sell a customized product. I can bring down the cost, low prices, and of course keep changing the mobile model much faster, market beating lead times by having a smart supply chain. So I need to increase my efficiency. And of course the last one, which I will explain from the lighting manufacturer, is the smart services. That I need to be a service-based one. Okay, so what do I need to do? So I've given a graph here. This is how we look at various industries across the various countries, how we do. I'm not going to explain much on this, but we start off from maturity assessment, identify the opportunities and threats, and then go into the strategy of implementing Industry 4.0, and then a roadmap, implement the roadmap. You require a complete digital leadership, transparent leadership to do this. These are the basic steps in implementing I4. Okay, the last slide before I end is, is this one. There are three things which many Indian industries need to keep in mind and which you students need to keep in mind. The future requires skilled workers. Just doing engineering is not going to stop your progress. You need to do some kind of skill development yourself. You need to advance yourself. So there are going to be a lot of skilled workers requirements. So from the industry point of view also, they also require a lot of skilled workers. So you need to look at this. You have a lot of products available in the market which are going to be customized. So look at learning certain design courses, certain like what I explained to you, computer-aided manufacturing and all those things, because you want to have decentralized decision making. And the last point which I would like to end, because this is the main point in which I'm seeing a lot of Indian students working on, is the big data analytics. So you need to invest. Colleges need to invest in some amount of research, some amount of professional development. They need to talk. They need to join hands with industries. If the industry is not willing to join hands with other colleges and bring out this field, big data analytics, into some kind of an Indian successful model. We need to look at these three things to implement Industry 4.0 really quickly. I think many of us, see, when I'm talking of availability of skilled workers, please remember India has the largest pool of engineers available in the world now. The number of engineers in India is much more than the entire population of Taiwan, entire population of Australia. It's unimaginable. I mean, we have so many engineers available with us. Why do we have just one Tata Steel plant in Kalinganagar? So that is the point. So let me end on that, and I'll take questions based on what you have. Yeah, so thank you. I'm ready for any questions.
Okay, sir, there are some questions are there from the audience. Hello.
Yes, please.
Okay, first question from the Srinit Lambodari. Sir, as you said that China is at 23% at Industry 4.0, but as the current condition of the global pandemic, the industrial areas are changes their location and thinking about the coming in India, so the 4.0 percentage will increase in India. Is it true?
No. I mean, this is all newspaper, or you must be seeing a lot of news channels on this. I don't think many industries will shift from China to, just imagine, will Apple shift from manufacturing Apple mobiles from China to India? I don't think it will happen. See, you need to understand, I think many students need to understand that China is technologically far ahead in terms of investment and manufacturing capability than many other countries. It is impossible to shift factories now. If you look at the manufacturing lighthouses, close to 1/3 is in China. About 16 factories are in China. So it's unimaginable to think those 16 will ship from China to India. I mean, this is only what you hear in newspapers and what you see in news channels. For most manufacturing industries, the pandemic has got nothing to do with their manufacturing. I mean, that's more of a political game, which is between US and other countries. So let's not get into that. Yes, India needs to bring in some amount of manufacturing into India. There is no doubt about that. Today, if somebody is talking of shifting from China to Vietnam or China to Philippines, it's not that they are shifting. It's that because their production is increasing, they need to increase their output. So they need to build another factory somewhere outside. So they are already thinking in terms of Vietnam, Philippines, Indonesia. They are already thinking. India is slightly behind in terms of investment, which all of you know, for various other reasons. Land and finance is something which is still not being tackled. So I don't think many factories will come into India. Is that question answered?
Yes, sir. Okay, next question, sir, from the Abhishek Davre. Keeping current situation of COVID-19 in mind, many students must have changed their mind in pursuing post-graduation or any higher degree in the European countries or in the US. What would you like to advise such students? And please tell what are your experience that you felt India is lacking or ahead in the industrial point of view as well as the consumer point of view.
Okay, first of all, please remember you need to get this COVID or Corona. You're fighting a war, or it's you're fighting a battle, or you're fighting. It's not a fight. It's not a war which you're fighting. You first get that. I do agree that even the mobile, when you ring up somebody in a mobile, message keeps saying that it's a war, it's a fight, it's a battle, and all this. These messages keep coming. You take the newspaper, you see that. COVID-19 is something which all of us have to agree. Till the vaccine comes, it is going to be there. Let us accept it. It is it's a thing which we will have to accept. It is going to be there. Many of us are going to get it. There has to be an herd immunity before we get over it. So let's accept it. The situation has to be accepted first. It's not a battle. It's not a war. Number two is going to countries abroad. That is going to start maybe in another 6 months, 8 months. It is definitely going to start. It is not going to stop. Even the flu pandemic in 1918 was there till 1920. After that, it subsided. Of course, the vaccine had come after that. So, going abroad, I would recommend those of you who got some amount of money, please do go abroad. The kind of facilities which you see there, especially in the US side, Germany side, innovation is tremendous. So, you get to work practically on the innovation you want. Like if you go to Japan, you will be working on smart society systems, so which you don't see in India, unfortunately, because investment or research is not much in India. So yes, you need, if you are planning to go abroad, please do go, but not this year, maybe end of next year. What is the difference between India and abroad? Basically, let me put it like this, which I think I've told it in your college. It's the crab mentality. If a person is good and he's climbing the basket, then 100 crabs will pull him down. So you go to a fish market, what do you see? If you see a crab basket, one crab tries to come out, 100 crabs will pull it down. So that is what is happening in India. If a person is good, you will find that 100 people pull him down. So you don't see much of progress in the good people, around. But they go abroad, they go to US. You will find Pichai becoming the boss of we have Microsoft, Google, IBM, everybody being headed now by Indians. But I don't think that will happen in India. So this is the difference. I hope I've answered this question.
Yes, sir. Thank you, sir. Next question from Professor N.B. Gurude.
Okay.
How to keep balance between technical knowledge, skill, and field experience in 21st century of revolution?
Yeah, see, this is something which I've been talking to a lot of colleges and a lot of industries. What you see abroad, you will find the staff, the college staff, and the students becoming interns in industry and working there and gaining knowledge. Similarly, you will find a lot of industry people coming into colleges, teaching and becoming research assistants or research professors. This kind of a crisscross activity keeps on going. You find this even in countries like Bangladesh or even in Pakistan. It is happening. But unfortunately, in India, this is most unfortunate. It is not happening. So for example, if an industry person goes to a college and says like, I want to work, it does not take place easily. He doesn't get hired, or the colleges think that, there is not required because I have 25 years of teaching experience. So I don't want somebody from the industry to come here and teach. Similarly, when a college person goes for an interview to the industry thinks, he has taught in the colleges, he is not good for the industry, he is not fit to work in the industry. So this is happening in India. So you will find this is a big mismatch which is taking place. Yes, I do agree we need to change this attitude. And I think this attitude will change only if colleges start taking there was an AICT rule that at least 20% of the staff should be from the industries. I don't know where this rule has gone. There was a rule earlier, I think 20 years back, at least in 1998, 99, I've seen many of my colleagues. An armed forces officer could have just walked into any university, any officer, and become a professor straight away. This was a rule from the UGC those days. But this rule is now being covered up, I don't know by how it is, where it has disappeared. You don't see any armed forces officer anywhere. So we lose out on experience. Similarly, the industry is losing out on experienced college staff. I do agree. So if your college can start this kind of a networking, maybe your teaching staff will improve their field knowledge considerably. Have I answered?
Yes, sir. Yes, sir. Okay. Next question from Maheshwar Jayesh Pai. Will it be easy for production engineers to learn cloud computing and edge computing?
Yeah, definitely. Why not? I mean, what is stopping you? If you are interested in, you first need to understand whether you are interested in this field. You need to first read about the basics and see whether you like that area. Don't go into it if you don't like it. Like for example, if you want to do 3D printing, you should know material science. Don't go into 3D printing if you don't like material science. I mean, that's the kind of connection which you should have. So for cloud computing or edge computing, you should understand a little bit of computer science, a little bit of electronics, and a little bit of mathematics. If you are interested, and I think from my side, this is the best field to work in now, because big data is the field in which a lot of Indians are working on. Edge computing has just come in. It has just started. So if you're a third year student or a final year student and you're interested in this field, go for it. Just jump into it, start learning. That is my tip.
Okay.
Yeah.
Thank you, sir. Next question from Pratik Patel. Industry 4.0 is all about the automation and computing. So all the data will be decentralized and automatic. So as per keeping eye on employability rate, will Industry 4.0 be productive in India?
See, this is a question which we keep hearing from government when we give presentations in the government sector. On the same question comes: will it cut jobs? Will it reduce employment in India? If it has not reduced employment in various countries, if it has not reduced employment in Tata Steel plant in Kalinganagar, which is an Industry 4.0 compliant factory, why are we afraid? It has not reduced employment in fast radius company in US. It had 31 employees earlier. It has 31 employees today. The difference is out of 31 employees, 26 have become highly skilled in their field today, much more skilled than earlier. So my experience and what World Economic Forum is also saying is, yes, a little bit amount of unskilled jobs we are going to lose because of robots and cobots coming in, because of artificial intelligence. Definitely some amount of jobs we are going to lose, but there are other areas which are going to gain jobs. So you took the example of edge computing. This was a field which was not there earlier. So there are number of engineers which are going to come into edge computing, fog computing, which are going to work on this field. It was not there earlier at all. So the level of jobs will remain the same. Only the fields will change. So don't be afraid. No jobs are going to reduce. This is something we need to, exactly like Corona, COVID, please get it out of your mind. We are not going to lose much of jobs. Yes, okay. If you just do basic engineering, maybe you lose your job. You need to be skilled. So you need to do some skill development. Yeah.
Okay, sir. Thank you, sir. Next question from Mahesh Nerkar. We have two more questions only. Sir, after lockdown period, government said many companies of America and Korea, which is now in China, will shift in India. Can it will be provide more job opportunities to freshers? Yes or not?
I think I've answered this question earlier, but anyway, no, not many companies are going to shift to India. I mean, this is something, at least in my experience, I've been talking to a number of people in the last 2 months. This is there only in newspapers. No, not many companies are going to shift. What is going to come into India is a lot of American companies or Korean companies, they want to manufacture inside India because their output is increasing. They are not able to manufacture in Korea and supply it in India. So they need to, start a factory inside India. So you will find some companies definitely in the next 1 year or so, they're definitely going to start their operations within India. Talks are already on. I mean, a lot of companies are already in talks for land and other things. As far as jobs are concerned, you see, the big mistake is there are too many engineers available now. And the number of jobs in the engineering field is not matching with that. But I think 16 lakhs plus is the number of seats available. Out of 16 lakhs, some 12 lakh students are doing engineering. Now for 12 lakh students, the amount of jobs available is only about 6.5, 7 lakhs. So around 5 lakhs will go jobless. So this is irrespective of whether Korean companies come in or not. This mismatch will be there for another 4-5 years till AICT closes down some colleges. I mean, this is a hard fact which many of us have to understand and agree. There's going to be, at least to my knowledge, around 20 to 30% colleges closing down in the next 4 to 5 years. Then maybe the situation will ease out and all the students who are doing engineering will get jobs. So that is the connection. Don't connect it to US Korean companies coming in. Okay.
Okay. Thank you, sir.
Thank you.
There is one more question from Dr. Bhavesh Kumar Patel, but he already got the answer from your previous answers.
Okay.
So I want to thank you, sir, for accepting our invitation and giving such informative session on transforming towards Industry 4.0. Thank you so much, sir.
No, not at all. I mean, it's a pleasure from my side. What I would suggest is if anybody is interested in going forward, my email ID is available, my presentations are available.
Okay.
Please go through them, and if you're willing to work in this field, some of you, please do let me know. We can join you to the big group which is already working. And I assure you, I can tell you with authority that this is going to be an exciting field in which a lot of development is taking place. And I want at least 1 or 2 Nasi colleges to participate in this. Unfortunately, the industry doesn't seem to be listening, but at least if the colleges, I think, join in, you could be participating in quite an exciting world which is going to come in the next 5 years. So thank you, thanks to all of you, and I hope it has been useful. If you require, I can go into a slightly more in-depth, but then I would suggest that only if you really understand what we have been speaking of. So thank you, thanks to all of you. Hello. 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 Hello.
Hello. Yes, sir. Hello.
Yeah, can you hear me?
Yes, sir. Yes.
Okay. So.
Okay. I am also thankful to Dr. K.N. Nandurkar sir and Dr. P.J. Pawar sir for giving this opportunity for coordinating this event and guiding to coordinate this event. I am also thankful to Professor Khalkar sir for give publicity to this event. Okay, and I am also thankful to all the participants for showing their interest in this particular webinar. Thank you, sir.
Thank you.
Okay.
Thanks a lot. Thank you.
Okay. I am ending the session. Okay.
Thank you.